Well, the next thing that happened in quantum theory, some time had passed, and a physicist named Arthur Compton had the idea that, okay, if light is really made of a photon, we specialized it by calling it a gamma, section 39.3, and it hits an electron, then the two are going to scatter. They go off in two directions. Electron go one way, the photon go in another. And I can look at the angle between these and see how they would behave. Is it true that light is a particle? He was asking. If it is, he showed that the equations you get by scattering a photon particle from an electron are different from Maxwell's theory, which is correct. The Einstein view or the Maxwell view. Well, this was done by Arthur Compton in 1923. It might mention, it was interesting on the side that when I did my undergraduate work at Vanderbilt, I took a course in the philosophy of science from a philosophy professor who was the son of Arthur Compton. So it makes sense that he went into philosophy. So Arthur Compton did this in 1923, and what he was able to show is that the wavelength minus the original wavelength, the new wavelength, was h over mc times 1 minus cosine theta. And this equation differed from the equation that would be predicted by Maxwell. So Maxwell's theory of electromagnetic radiation was actually wrong. Light is correctly identified as made up of bundles of photons by Einstein. I put a check mark there because Einstein was correct. And this equation, which I'm not going to try to derive, can be derived from the scattering and how the wavelength would change using the principles of relativistic conservation of energy and conservation of momentum in the scattering process when they scatter by an angle theta. So basically that showed that the Einstein photon hypothesis was correct. Remarkable experiment.